Hi everyone, it's a pleasure to present something exciting for you today. So I would like to describe a bit in high level on what I'm planning to present today. So let me share the screen. Okay. So today we plan to build AI junior cloud engineer, and this engineer will be capable to write code, run some tests on this. And actually, when it's tested, executed, it's workable code, it will return it to us. So it is the idea of current exercise, today's exercise that we plan to implement. And I think that this can be really useful for people, first of all, for engineers who daily write code. Maybe so it is a cloud engineer right now, but that is easily can be adopted to your use cases, like if you're a developer, if you write in unit tests, etc. So you can adopt it to improve your workload and more efficiently, but provide in better code. So that is one case how it can be useful for you. From another standpoint, for example, you work at software company, you provide services to your customers, and you would like to improve your services, become more cost efficient, so you can develop something in your company that will enable your developers to do something like this. It is a second way, and kind of like third and very applicable to today's topic. It is a cloud engineer. So this cloud engineer is capable to generate structured code. So with generated code, you can deploy the infrastructure. So the something can be very useful for companies that or people who provides migration services to the cloud. So you can, for example, upload a diagram, write some description, and AI will generate a code for you. So that is kind of like brief introduction of what we plan to talk today. And I would like to also add that we will do more like code generation exercise today, but that doesn't mean that this solution is just for code generation. So what we will develop, it is a solution that can do different things, generate different artifacts. So potentially that framework can be adopted for generating different artifacts like marketing materials, like some reports, and so on. So first of all, you already may know familiar with RAG. So it is retrieval augmented generation, where we have a question, we have some index database or any other databases where we have some knowledge corpus, we have large language model, and the answer. And you can see that it is a linear. So we have only one way. It is from question to documentation to large language model to answer. So it's no options to generate something else. So if we go to beyond of this, we can use, for example, routers. And let's say we have a question, and based on the question, LM can use either index database or some other resources and tools, and just allow you to add some logic to your application. And if we go beyond of this, and it's actually what we plan to implement today. And the second version is this: you don't have any cycles. So you have start with the question, you have some actions in the middle, and the answer. There is no cycle. So if you cannot implement some kind of a loop, you cannot get a feedback loop, and so on. That's just linear. And third one, and I think that it's very useful actually for code generation, where we, if you imagine usual coding experience, you're writing a code, you're trying to run it, it fail, you read the error, Google the error, find the answer, fix it, try again. So it is very stable process, highly repetitive, and that is where AI really game changer, can be game changer. So what is a state machine? So state machine allow you to distinguish business logic from execution. So you can build a process, or that can be business process, code development process. And in this process, you have nodes and edges, and you do these activities in states. You have states, for example, your code, and you can do activities like run this code and test it, or generate your code, and so on. And for example, and we can implement here a feedback loop and rewrite it. For example, we capture the error and send back to regenerate step. So let's go a bit lower, what we have here. So it is from another perspective, a RAG. That is a chain, classical chain. So we retrieve document, we have relevant document, and we use LM to generate the answer. How state machine can help with your RAG implementation. You can retrieve the documents, you can score these documents, and you can use LLM to check if this documentation is relevant to your question or not. And if it is not relevant, you rewrite the query. So you have this feedback loop. So you retrieve more documentation that is maybe will be more relevant to your question, and repeat the process until you find some relevant documentation, and then you will run a generation node and get the answer. So it's how state machines can significantly improve quality of retrieval augmented generation. And today we will implement something like this. I think I can switch to another tab. Yeah, so it is a LangGraph technology from LangChain, and this allow implement actually the state machine. So first one, we start with the question, then we try to generate some code. As you're a developer, you can write some code, you can Google it, copy it, and start. And actually, what you get, so it is a code and some description of this code. So it is a state that is stored in the graph. And then what we're trying to do is execute this code. So we try to, if we're talking about AWS CDK instructions code, we're trying to generate this instruction. So that is actual execution. And during this execution, usually when you just started development, it's often fail. And if it fail, we capture the feedback. So we capture this error and return to the process of generation. And that will repeat until you reach your maximum retries, or you generate actual code that works. And with this solution, you also can integrate some tools like API documentation, maybe Google API, so you can Google the errors, you can attach code samples, and so on. So there are a lot of potential on how you can improve the system. And before starting the coding, I think the last theoretical part, it is how usually, so let's say you need to develop the code. So first iteration, you can write everything by yourself. You can you can code it fully from end to end. So next one, you can use LLM. You can just try it once, generate it, and yeah, that will be just only once, and you can use it whatever you want, and rest of the steps you can write by yourself. You can use chains that will allow you to do some multiple steps. Routers, as we already mentioned, you can so the router can decide which step to take, but it doesn't have cycles, as we just mentioned. We have state machine. that allow us to do cycles. And we have a full end-to-end agents that can generate the code. They can decide on tooling, which steps to take, and they can decide which sequence of the steps it can take. Currently, agents not as advanced, and for example, state machines for me give much more advanced outputs for code generation. So that is why today we will talk more about LangGraph and state machines. Okay, I think we need to share the repository. You can go together with me. Let me send you a link. So you just need to clone the repository. You may need a few variables. So you have a sample. In this repository, you have a sample and file. And so most of the code will use Anthropic API key. So you need to go to Anthropic if you don't have it. Register there, it's quite straightforward, and generate API key. And in order to see the tracings, in order to see all the requests that was executed in some logs, you need to register with LangChain or Langsmith. Let me check, let me show it to you. So first of all, we have Langsmith. Settings, yeah, API key. So you just need to generate new API key. Let me send you a link. So you need to register here to stop the variables, and you need to register in Anthropic. So get started. When you finish the registration, you just need to click on Get API key, create new key, and that will work for you. Okay, so I don't think that we need fireworks today. So we will just use the solution that I will present, only one. Okay. So I hope you configure it, or will watch and later will test the solution from the GitHub. So next step, you just need to load this environment. So you created a .env file, and that command will upload it. And next one, what you need to create, it is actual LangGraph state. So it is a representation of your graph. It's where you persistently store information between steps in the graph. So just initiation, quite straightforward. Also, I put some color configuration just to make it looks more nice. So let's go further. As we mentioned, we have nodes and edges. So edges connect the nodes. So first of all, we need to create a nodes. So I use class nodes, and we have some initiation, like which model we will use. We will use Claude3 Opus. It also works with smaller Claude3 models as well. So that works quite well. And yeah, initiation is just some variables here. And next one, we have actual node for generate. And this one, it is a generate code solution for you. We have some states here. So we store iteration, number of iterations that already happened, and query, question. And next one, it is actual class code that is actual store the information about actual. So it is actual output of this node, and we output prefix. It is description of the problem and approach, and the code itself. In our case, it is a CDK code. Next one, we need to initiate a long anthropic model with the tool. And here we bind it with the tools. And we identify that it is a code. And last piece, oh, maybe not last piece, we need a parser. This parser will, so a LAM model return kind of like plain text, and we need to have a parser that will be able to parse this output and capture all these details, like, so it will distinguish prefix from the code, and it will be as a dictionary. And also we use a prompt. Let me show you. It's what I created for this demo. How to hide it? Come on. So you need to go to LangSmith, and actually you can find this prompt with a name, or for me, it just my prompts here. And let me check what is an AWS CDK engineer. Yeah, this one. And let's check what we have here. So on the left, we have a template. This template follow Claude best practices, and it has requirements on this format, like 2 spaces here, then human, it is instruction from the person, an actual prompt, and at the end we have assistant. So it is requirements. And we have 4 inputs, like a context, question, generation, and error. So we distinguish them. So we can embed here context. So here you can, for example, integrate it with Google search, or integrate it with your RAG system, and actually retrieve code samples, retrieve API configuration, and so on. And that will be here. The next one, we have some description, how it should be developed. We have a question. We have generation. This is a previous attempt to generate. So we have this feedback loop, and we have previous error. So if we have previous attempt, that means that it failed last time, and we are trying to regenerate. So that is why you have here generation as well as error. And I also provided a sample. This significantly actually improve performance for any large language model. So when you provide some samples of what you would like to get, it's actually perform quite better. There's just a code sample. And that's all. So it is quite straightforward prompt. Let's go back. And we set up a chain. So that is the input for this chain. We already talked that we have 4 inputs that we identify them here. We have actual prompt. We have our LLM with tool, and we have parser. So it is join everything together to one chain. And that is only one node in the graph. So, and we have here 2 conditions. first condition if there is error, and we are in regeneration solution step with error feedback, or it is an initial generation. If we don't have errors, that means it is initial generation, and we just generate without an error feedback. So that is the first node that we use. If we scroll down, we have check code execution. That actually synthesize, so it captures the code and try to synthesize actual templates that will deploy the infrastructure. So, and if this synthesization process failed with an error, that means that code is wrong, and we will capture the error. So I'm not really sure if you're familiar with AWS CDK command line interface, but it's just very straightforward. This command means that we have CDK code and we generate actual YAML template that will describe different infrastructure elements like network, like virtual machines, connection between them, and so on. So that is command that is execute and with our code, and we capture errors and outputs. And if it is failed, we capture the error and actually return, sends this back to, so it is just returns the error, yeah. And if it doesn't fail, we return success. So we return that error is none. And we have finish phase, just last step, last node in the our graph. We have extract response. This is graph state that extracts the state. And I think you will better understand how it is connected lower, because edges, it's actual connection between different nodes. And so we identify edges, that is actual connection. So we connect generate and check code execution. So we generate the code and then execute it. And next step, it is conditional edge. So we have here a statement. So if code executed without errors, we will go to finish. And if it is executed with error, it will go to phase generate. So it's what we actually identifying here. Just a moment. Decide to finish. I think it doesn't use this one. Yeah, this command is not used. So yeah, we use this one, decide to finish function here. And this function check if there is error in the output from the generation step. And if it is the error, it will return finish. If it is if it is error, it will return generate step. If it is no error, it will finish and return finish word. So that is nodes and edges, and we identified, if I scroll up, we identified this node and this node and this node, actually, that is check fail or not. And we have all these edges like that connects generation with code execution with check. And if it is a failure, it will return to generation. So we identify all these edges. Scroll down. And then we need to set up the agent that will execute with this graph. So the graph, it is instruction for the agent. and it will go through the steps and execute it through them. So what first of all we need to create an actual graph. I doesn't use context retrieval thing because I tried with actual documentation. I didn't spend enough time, and actually LM worked better without my document retrieval process. So that is why I commented it here, because it works better. We identify nodes. So it is our class that we created earlier. So, and we initiate and add all these nodes to the graph. And then we create all the edges for the graph. And we set entry point, this generation node, and finish point, it is a finish point. It's finish node, sorry. Okay, that I think main part. I will skip for now application part because it already should work. Let me execute step by step what we have here. So it is we create nodes, then we create edges, we create agent, and then we can scroll down and create a function. So we already can use it without this function, just this some more abstraction here. And I just create very simple instruction like as default one, create VPC with 2 subnets. Then I execute it. And then I can trigger actual my agent, and we will see how it will work. Yeah, sorry that for so long introduction. It requires some initial setup before we can see any results. And let me show you how it looks in the LangSmith. Yeah, you can see this LangGraph. If we open it, we can see some start, edges, and the first step it is generate. You can see our question. The iteration is 0. No errors. What we have next? Yeah, so it is starting from here. You can see it creates, you can see our prompt actual. So you can see it doesn't send any documentation. I have a question, description, no previous attempts, no errors, and that is actual code generation process. And this code generation process have a prefix, like description, and it has actual code. Yeah, that's for some reason it's executed from first try, so it works quite good, and it's not happen always. So let's try to get exception and get error and see how the model can execute and fix this error. So currently we have actual 2 execution at least. Yeah, 2 of them. Let me click scroll elements. Let me show you how it was executed. Okay, so we have phase generate solution. Then we have phase checking the code execution. Here you can see actual generated code. And let me remind you what I put as a question. So I ask this AI engineer to create a EC2 instance with latest operating system, run web server and enable it and run it. So we are running web server on this instance, and ask him to install it to public subnet and install it to my existing network in my region, in my account. and yeah, describe the port that I want to open to the internet, and I ask to secure my volume store to encrypt it. So you can be not so specific as I did. I think the solution will will set up some default values for you, but I try to make it more difficult, as I think, for AI cloud engineer to do more work. And if you scroll down, you can see this actual code. You can see our stack with actual virtual machine that use the latest operating system. You can see that it uses my network. It opens ports. It uses public subnet, and so on. So you can see all this configuration and actually install a web server on the virtual machine and enable it. So it will be running, and if it deploys this script in this environment, you actually will be able to connect to this instance and see response. And you can see it captures the error. So cannot retrieve values from the context VPC provided. So I think it cannot find actual account in region. So I specified this information, but it was not set during the in the code. So it got this feedback, and actual next iteration, if I scroll down, I will see this environment variable that was created, and it was attached to actual my stack. So the next step, when we try to execute this code, it finished successfully and it's done. So it works. So congratulations, our solution in notebooks works pretty well. And what I propose to do next, it's actual operationalization of the solution. So notebooks is great, but we would like to see more like maybe web interface or any other application convenient to users. And what we need to do next, we need to create API in order to be able to connect to this solution and trigger it and get the response. So in order to do this, I used Fast API. It's quite simple solution. You can easily to start using it. I enable some headers and so on. And what I'm doing next, I'm using LangServe. It is a package from LangChain that allow us to easily integrate with API this LangChain graph that we created. And you can see this. So we created this web app, and we attached to this app the chain of the LangGraph, and we specified the path. So what we need to do next? Okay, that is actually a code in the notebook, but it will not work because it is notebook. I open the we have a separate file in the repository. It's called agent.py. It has the same code as we discussed before, and at the end it has actual this API, and it has actual command that will run our API. So what we need to do, just a second, I will type Python agent. And what you can see, we have the link. We can click on this link. Yeah, of course, on the root, you don't have anything. But if you go to, just a second. First of all, you can go to docs and see the whole API documentation. I think it doesn't surprise you if you often work with API, it's just generated on the fly. And what we can do next is quite a cool thing from LangChain. It's actually playground. So we can use a playground and, for example, type VPC with to public subnets. Yeah, maybe that example is not fully applicable to you. Maybe you're not a cloud engineer, but trust me that something can be really can be adopted to your cases of code generation. So let's imagine it can generate Python code, it can generate JavaScript code for your application, and so on. And here we can see all the intermediate steps, as we saw in, yeah, there are a lot of text. I will not go deeply here. And you can see this executed and the output is here. So API works. We have tested it. And what I would like to do next, I would like to create some nice user interface, not just playground, but user interface. So in order to do this, I created some function. This function will parse the output from API, and actual functions that use request and use our API in order to get the generated code. So let's execute it. So this command will walk through the API. So we're just testing it. And below you can see how it works on backend. So currently we have front end and backend part. And you can see this face generating solution. Okay, that is done. You can see this stack and CDK code is created and tested. What I'm going to do next, I'm going to store this file, this code to the file. And I'm going to execute this code just locally. So you will see if it works or not. So this is my file that was generated. And then I executed it. And that code generates this template for my infrastructure. So you can see the subnets and a lot of different details. I don't think that we would like to deep dive here so much. So yeah, we can see this code works. And I think the last step, what we would like to develop is, so we put architecture description with the text, but sometimes, quite often, we have diagrams, architecture diagrams in our documentation. So that is something can be very useful as an input. So let's imagine instead of writing some description by yourself, you can just, as an input, put your architecture diagram of the AWS architecture, and then it will generate on the fly the description for you, as well as it will generate a code for you. So just a dream for cloud engineer. So let me show you how looks the diagram that I created. Very straightforward, very simple. Remember that this engineer is junior, and this one, yeah, it works with simple things quite well. I didn't test it on more difficult parts, but you need to understand that if you provide LLM to just very difficult diagram, that usually person who works on such solution development usually split it to different tasks. For example, let's imagine you need to set up a significant architecture with data lake, with applicationware, and so on. And if you give this task to your team, usually it's split to different components, like this is component for data lake, this is component for network part, and so on. And as a next iteration, I think this solution can be extended with some initial steps that will split your bigger task to more granular one, and then executed them in parallel. So that is something as future extension. So currently it works with something quite simple. I mean, few elements. I didn't test it with a bigger one. Maybe it will work, but not as stable as this works with small one. So I showed you the diagram, and what we can do, we can use a Claude3, and Claude3 now currently supports image as an input. And what we can ask LLM actually analyze the diagram, capture all AWS resources, configuration and components, and relationship between them. So we ask LLM to analyze the image of the diagram and create this description that will be detailed explanation for the next step for our AI cloud engineer. So let's execute it. Yeah, that is done. It is just a function. And then identify image and actually run my function and print the description. Okay, that is done. You can see this, long chain PNG. I think I put some wrong image. You can see this analyzed actually on my nodes and long graph. So I need demo diagram. Let's execute it again. So I think we will have time. So you can see this diagram describe pretty well the architecture that is on the diagram. And then we use it, so we then combine our message that we can write by ourselves with actual descriptions that we generated. And then if I executed it, we can see how it works. Yeah, while we are waiting, I think I can switch a bit to next steps. So I mentioned that yeah, it's actually finished. Yeah, not yet. Yeah, it's finished. So as a next step, I mentioned that we would like to develop some more senior UI interface that will allow us to provide that we can provide to engineers that will work with this instead of API. So I created Streamlit application. It's a very simple, I would say, constructor for experimentation. Here I put some function that connects to LangGraph and execute. This is functions that I created to parse. And this function describes actual diagram. So it's very simple. And if so, we have these functions, and then we have a form. As the input, we can put some text information, that is example. And as well, we can upload the diagram. And when person is submit this form, we analyze the image, extract the information, and then generate a code. So let's, so in order to run it, you need to, in app folder, so you need to, first of all, let me go to the root. You need to go to app and run Streamlit, run app, and execute it. Here you can see the example of the input. I just put it as default one. I can upload the image. Let me find this image in my repository. this one. Click magic button. You can see the preview of the architectures that I uploaded. Yeah, we will not see here intermediate step and logs. So that is why I think I can open it here. Yeah, you can see this this part. You can see description of my diagram, so it's already executed. And you can see the phase is generate solution. Yeah, we are waiting.
While we are waiting, here is one question inside of the chat. So perhaps, Artem, could you please go to the chat?
Okay, regarding execution, yeah, actually currently I doesn't deploy the code, and actual implementation I also didn't mention. For now, it is just run exec command. Yeah, it's run a bit different command, but it's actually executes the code inside of the code, and that is something that is has security risks. So that is why I didn't deploy this application publicly, because I need some sandbox isolated environment for my tests. So currently, I doesn't deploy the actual architecture at all that's generated. I'm just synthesize it. So how CDK code works? You have CDK code that is actual Python code, and this Python code it has the same. It has the same things like classes, functions, cycles, and so on. And that is how more modern way to the instruction. So we use CDK. And the next step, we doesn't deploy to AWS. Next step, we generate the template that's called CloudFormation template. That is actually actual template that describe resources, and that is something that can be directly already deployed to AWS. I think we can try to deploy it, this code. Yeah, yeah, dry run mode. Yeah, it's actually more like dry run mode currently. So I'm just synthesizing it, but doesn't execute it. And the risk, why currently executing code inside of the code is risky, because that is not isolated, and actual code is generated by LLM. So we can imagine that we can ask LLM to generate some exploits and actually execute it and actually hack your web server. That is something I need to fix before releasing something to production. So if I will find the code, so it should be in agent in this test phase. Scroll up. Yeah, this one, sub process. We use this function, and we actually run the Python code, just synthesizing it. And this is something as I think it's quite risky to do, and I need some my kind of like guess how it can be easy implemented. It is use some Lambda functions in the AWS or some containers that will run isolated in isolated mode inside. I can run this code in the container. So it's what I think I can implement in the next iteration before deploying something. Okay, I think we should have the architecture. Yeah, it looks nice. So you can see some description that it has web server and so on. And you can see actual code. That looks nice. And yeah, we can try to deploy it. Let me show you how to deploy it. So I copied this code. Yeah, I already have this Yeah, so that is actual synthesized code. So we can copy it. Just a second. Or maybe I can use this file. Let me check. Yeah, we can use this file. I will copy this file to some folder. And then I can go to my console, to AWS. So you can see the console. Let's go to CloudFormation. Create new stack. Template is ready. Yeah, let's upload the template from my home repository. Progress, next. Oh, I think it's, yeah, let me check this code again. I think I know the reason why it's failing, because it's a return warnings as well. TM. No. Oh, yeah, that is CDK code. That is not actual. So I need to generate, from this I need to generate the code itself. So that is not CDK. Let me do this. CF YAML. Okay, that is done. And then I can open the file. Curious, where's the file itself? Okay, this one. Interesting why it doesn't show up. Hmm. Okay, something wrong. I'm not really sure the reason. Oh, I think I need to run this command. Then it will work. And then I will YAML. Yeah. If I open it, yeah, you can see all these resources. And now I can deploy it if I go to repository. Next one. Yeah, now we can put name is to base web. Next. Come on. Okay, something. It failed for some reason. Okay. Yeah, so requires more tests. Yeah, I think it has some wrong attribute, but synthesize didn't capture it. It's quite weird. Why? So yeah, it's maybe not fully works. I think yeah, we need to test the solution better in order to make sure that it provides yeah, to make sure that it provides workable code. So in current iteration, it just generated, it seems like code is workable, but not really. Okay, I think as the last question, we can talk about how we can improve solution. Yeah, make it workable for sure. But what actual steps and notes you would like to add here? Some verification, deployment, integration. Maybe you would like to add it task to Jira.
Artyom, and what did you do to improve this solution for your tasks? So maybe you also have some kind of example for the audience.
So as I already mentioned, I would like to run tests in isolated environment and actual do tests better. As we can see, synthesize CDK code to the template didn't capture all the errors, as we can see. That's some potential issue. Voice message control. Yeah, you can integrate it to stand up and actually get task on the stand, maybe not on stand up, on planning, and actually already to deploy code also the planning. That will be nice. So back to how to improve. Yeah, run in isolated environment tests, add more tests because we can see the errors are not captured. I would like to add as a final step. I would like to add deployment. Maybe some human. So you capture input from the human, like approve from manager and deploy. So maybe push pull request to GitHub. It would be nice. I also mentioned about tasks creation as initial step. So instead of trying to solve a whole solution through this one script, I think it would be great to split the initial task. Imagine you're uploading quite big diagram. It will split to iterations and it will go step by step, execute it, test it, and deploy it. And also, I think really critical, it is security tests. Currently, it generate and it's all only relies on my inputs. So, for example, if it doesn't say encrypt EPS volume, it will not encrypt. Or, for example, if I can say use SSL encryption in transit and so on. So if it doesn't say it, it will not do this. So I think as a next step, I also would like to see the security tests like on best practices and that will highlight to LLM issues in the code. So for example, let's imagine LLM generated a code, then we run security tests, and for example, we captured that EPS volume is not encrypted, and this error will back to the LLM, and LLM understands that, okay, in order to be secure, I need to encrypt this volume. So that I think these few steps will allow, I think, get more like production ready solution. Thank you guys for joining. Yeah, it was a pleasure.